Let's now solve a few exam questions regarding the SUVAT formula. Let me get my pen. The first one is this one. Spring 2013, question paper 41. Question 3. It says, the top of a cliff is 40 meters above the level of the sea. A man in a boat close to the bottom of the cliff is in difficulty and fires a distress signal vertically upward from the sea level. Find first the speed of projection of the signal given that it reaches a height of 5 meters above the top of the cliff, and then the length of time for which the signal is above the level of the top of the cliff. Let's look at the first question first. So you want the speed of projection of the signal given that it reaches a height of 5 meters above the top of the cliff, which was already which has a height of 40 meters. I made a sketch over here. So this is where the boat is. This is the cliff, and the distress signal goes a total of what? Of 45 meters up, right? So how do you solve this? In this type of questions, you always have to consider that the maximum height occurs when the final speed is 0. So that's what you plug in, all right? And you know the final speed. You want the initial speed. You know the acceleration, which is the acceleration of gravity. So 10 meters per second square. So you just use v square equals u square minus 2g h. You work this for u, knowing that this is 0. Substitute the values, and you have a speed of projection of 30 meters per second over here. On the second one, it says that it asks you the length of time for which the signal is above the level of the top of the cliff. So you want the time it takes for the signal to pass this edge of the cliff, go up and go down. All right? So what's going on over here? The flare is going 5 meters up and then 5 meters down. We can call the time for the flare to pass over here while it is going up as t1, and the time when it goes down as t2. And you pretty much know everything that you need to know in order to get the information that you want. Look over here. If you apply this formula, s equals ut minus 1/2 of gt squared, don't forget that the only acceleration the flare is submitted to is the acceleration of free fall, right? And if you plug in the values that you know, right? The height as being 40, all right? The speed, the initial speed as being the speed of projection, which you already calculated, and g as being minus 10. And if you solve it for t, what are you commanding, so to speak, the equation to tell you? It's asking you to, the equation is going to provide you the time it takes for the time it was when the flare was at this height over here, 40 meters, right? And let's see what happens. You already know enough probably to understand this. This is solved in relation to t, right? What type of equation is this? Is a quadratic, right? So how many answers? What is the maximum number of answers that this is going to give you? 2. This is going to be the t1 and the t2. Want to see? So s is 40, right? That is the height over here. This is 0. You want the height over here, so 40. The initial speed is 30. 1/2 of g is 5. Now let's solve this. If you solve this, you'll have these two values, 2 and 4 seconds. So what does this mean? This means that the flare passes over here, the edge of the cliff, as going up at 2 seconds, goes up, then falls, and passes again at 4 seconds. So for how much was the flare in between these two values? Obviously, 4 minus 2, 2 seconds. Okay? Next question is, the man fires another distress signal vertically upwards from the sea level. The signal is above the level of the top of the cliff for square root of 17 seconds. Find the speed of projection of the second signal. All right, so this is a different signal. And now it stays not 2, but square root of 17 seconds on top of the cliff. All right? How do you solve this? You want to know now the speed required for this to happen. All right? The information that you are given is information about a portion of the way, right? You only have information about what's happening over here as the signal is above, passes the edge of the cliff, and then disappears behind it. And you want to know something that happened before, all right? So first of all, we need to use the information that you are given to calculate things that happen at the beginning of this motion, which happened already after what you need to know. What do I mean with this? There are two different ways, at least, to calculate what I need to calculate. The amount of time the flare is over here will allow you to calculate the speed with which is when it appeared beyond the edge of the cliff. And once you know this, you can calculate, once you know this, you can calculate the initial speed overall, which is the question itself. So if the signal stays square root of 17 seconds above the cliff, it means that it takes square root of 17 over 2 to go up and square root of 17 over 2 to go down. At the maximum height, what is the speed of the flare? It's 0 meters per second, right? So you can use this equation to calculate the speed at which the flare is over there when it starts going, when it appears here on the edge of the cliff, right? So this is 0. This is what you want. This is minus 10. The time is square root of 17 over 2. Work it out, and this is the speed at the edge of the cliff. Still not what you want, what the question is asking. The question is asking for the speed over there. But now you already have this, which is going to be your final speed for this section over here. This is going to be your initial speed, what you want. The acceleration is still 10 meters per second square, and the distance is 40 meters. So now you can use v squared equals u squared minus 2gs to calculate u, all right? So this is now going to be your final speed for this section over here, while it goes until there. U is what you want, minus 2 times 10 times s, which is 40 meters, the height of the cliff. Work it out, and you have a speed of projection of 35 meters per second, all right? See what happened here? You had to divide this motion in two different parts in order to get the final answer. You have to use the information that you were provided, which regarded just a portion of the way, all right? And then use this to plug in the other section of the motion to find what you are being asked. Next question. This is Spring 2014, question paper 42. Question 2. A and B are 2 points which are 10 meters apart on the same horizontal plane. A particle P starts to move from rest at A directly towards B with constant acceleration 0.5 meters per second squared. Another particle Q is moving directly towards A with constant speed 0.75 meters per second squared and passes through B at the instant that P starts to move. At time t seconds after this instant, particles P and Q collide. Find first the value of t, then the speed of P immediately before the collision. Okay, you don't have a diagram here. I always advise my students to make a sketch of what is going on, because if you can picture in your head the events that are being described, it's going to be much easier for you to solve a mechanics question. So what is being described is this. So you have here at the points A and B separated by 10 meters. You have particle P. I think the first one is P, the second one is Q, yes. And this one has an acceleration of 0.5 meters per second square and goes in that direction, right? And then you have this one that goes at constant speed of 0.75 meters per second. The velocity is going to be negative because it's pointing in the opposite direction of what you consider to be the positive direction, right? It says over here, is moving and it passes through B at the instant that B starts to move. All right, how did I represent this? I put here this t equals 0 over here. When this starts to move, this particle is at B, which is 10 meters apart. So all the information that you have is here. They are going to collide at some point in between A and B, obviously, and I call this point T, capital T. All right, so you want to know the time, is the time? Yes, the time of collision. What does a collision mean in terms of kinematics, in terms of mechanics? When you have a collision, means that the two particles are at the same spot, right? If they collide, they are in the same place at the same time, right? That's literally what a collision means in terms of physics. It's two objects being at the same place at the same time. So I called it over here just to have a visual idea of what is going on. But mathematically speaking, in terms of the laws of motion, in terms of the SUVAT formula, the collision will occur when the displacement of A is the same as the displacement of B. So if you equal the formula that allows you to describe the displacement of A to the formula that allows you to describe the displacement of B, you are solving this for the time, which is what you want, right? So what is the next step? Set up the formula for the displacement of A and the formula for the displacement of B. You have to choose our origin for the referential, so I chose here A, all right? So if that's the case, then the displacement is just ut plus 1/2 of at squared, right? U is 0, the acceleration is 0.5, so this is the formula that describes the motion of A, the displacement of A, in terms of t. What about that one? That one you have to consider one thing. Remember that S0 in the formula for the SUVAT formula, the S0 is the original displacement, and B, in relation to this referential, is 10 meters away, right? So you have to plug it in the formula. But it's moving at a constant speed, so you don't use the SUVAT formula, you use the formula that relates to constant speed, which is V equals S divided by T, S being the displacement. You have to work this out in terms of the distance or the displacement, so S equals VT, right? So the formula is just this, is 10 meters, the original displacement, minus VT, right? So 10 minus 0.75 T. This formula describes the displacement of B in terms of time. Makes sense? When time is 0, B is at 10 meters. When time is 1 second, it's going to be 10 minus 0.75. So this is decreasing as time passes. This is increasing, the displacement increasing as time passes. Eventually, they are going to be at the same place at the same time. So you equal this to this and solve. That's what I did over here. You will have a quadratic. You solve it. You will have two answers. One in one of them, you'll have a negative time, which is an impossible thing. The other one is going to be a positive time. This is the one that the speed of P immediately before the collision. This is a 1-point question. You just have to apply the formula, right? Now that you know the time, V equals U plus AT, U is 0, A is 0.5, T is 5, we just calculated it. So the velocity is 2.5 meters per second. Another one, winter 2015, question paper 41. It's here, question 7. A cyclist starts from rest at point A and moves in a straight line with acceleration 0.5 meters per second square for a distance of 36 meters. The cyclist then travels at a constant speed for 25 seconds before slowing down with constant deceleration to come to rest at point B. The distance AB is 210 meters. Find the total time that the cyclist takes to travel from A to B. Again, you just have the question with no diagram associated with it, or a graph. And in this case, in this particular case, since this is so traditional, so to speak, in mechanics, this type of motion in which you have an acceleration, constant speed, and deceleration, I just went ahead and I just sketched the graph. It takes literally just a few seconds to draw, and I have here visually all the information that I want. Most of all, it is a speed time graph or a velocity time graph, which is the best kind of graph you could have, because all the information can be retrieved from it. And this is what you have. Anyway, I wrote here all the information that the question was providing, and I advise you to do that as well. Once you have this, you don't have to read anything else, all right? All the information is there. So you have 3 stages. You have the initial speed as being 0, you have the acceleration, you have the total distance in the first stage. For the second stage, you have a constant speed, and you know the time at which this is taking place, so a total of 25 seconds. The third stage, you know that it is a constant deceleration, and you know that comes to a stop, so the final speed is 0, and you know that the total distance traveled is 210 meters. Total displacement, in this case, doesn't matter, one equals the other. So basically, I just put all the information over here. You wanted the time it takes for what? The total time to travel from A to B, right? So you need to know this. You only know this section, it's 25 seconds. You want to know the whole thing. So what do you need to do? First of all, you need to find this value V over here. Without this, you cannot do much, all right? You could use the gradient, but to use the gradient, you would need this and that, all right? So you cannot use the gradient in this particular case because you don't know what T1 is and you don't know what V is. So you have one equation for 2 unknowns. You cannot use the gradient. So you have to use one of the SUVAT formulas, and the one that you may use, because you know the acceleration and you know the distance it traveled, is this one. V squared equals U squared plus 2AS. U is 0, V is what you want, A is 0.5, S is 36, means that V is 6. Now you know this, all right? Now you know this. So now that you know this, you can calculate the total, you can use the formula for the total area to get the time, the total time, which is what you want. What shape is this? This is a shape of a trapezium. So this is 25. This side over here is basically what you want. You know the value of the area, so just plug in, all right? So 25 plus the total time times the distance between them, which you just calculated, is 6, divided by 2 is 210. Solve it now, and you have a total time of 45 seconds. Even though the question didn't expressly told you to do so, can you see the advantage of sketching a graph? You can use a graph as a tool, all right? It is much easier to solve this question using the area of the trapezium than using more SUVAT formulas to get to the same result, okay? Second sub-question is, 24 seconds after the cyclist leaves point a car starts from rest from point A with constant acceleration 4 meters per second squared towards B. It is given that the car overtakes the cyclist while the cyclist is moving with a constant speed. Find the time that it takes from when the cyclist starts until the car overtakes her. All right, 5 points. All right, in my opinion, this should be more than 5 points because there's a lot to it in this particular question. All right, I wrote all the notes that you need, and I'm going over them with you right now. All right, so we first need to calculate the distance that the cyclist traveled during the first 24 seconds. Don't forget that the car just started moving after 24 seconds. So in the meantime, the cyclist already was at a certain distance, and you need to calculate what distance that is. All right. So you know then what you know the acceleration and you know the speed. So the time, you rearrange this for the time. All right, it is moving at 6 meters per second. The acceleration is 0.5. So this is 12 seconds. What is this time that I calculated over here? This is a time it took for the cyclist to go from here to here. Is this T1 over here? It's 12 seconds, right? It's still not the 24, or better yet, when the cyclist is over here, the car wasn't moving yet. There were still 12 seconds to go, right? So do you see here what you have to do? You have to look at the situation that you have. Again, with the graph, it's so much easier to figure out where the cyclist is after 24 seconds. If you don't know this, you don't know where the cyclist is. Actually, you know, because the question tells you. You know that it is over here, all right? It's moving at a constant speed. But you need to know for how long the cyclist is moving at a constant speed when the car starts. And you cannot know that without knowing this time over here. So now that we know that this is 12 seconds, right? We also know that the cyclist still has 12 seconds to go at constant speed, right? So it covered 36 meters. You already knew that. Oops. 36 meters in the first 12 seconds. There is still 24 minus 12, which is 12 seconds. The cyclist moved at constant speed of 6 meters per second. So you can calculate the distance it traveled during those 12 seconds. You apply the formula for constant speed, solve it for the distance, and that is 72 seconds. All right? So what is the total distance the cyclist is when the car starts moving? It's 36 plus 72. So the cyclist is already 108 meters away from the car when it starts moving. All right? Now that you know that, to calculate the distance the car needs to cover to overtake the cyclist, you need to understand that when an object overtakes another, on that moment, the displacement is the same, just like a little while ago on the previous question with a collision, right? Now, the displacement needs to be the same, so we have to equal one equation of motion of the displacement to the equation of the displacement of the other object, all right? So it is given that it happens while the cyclist is moving at constant speed. So the distance is given by the formula for constant speed, right? It is Vt, the constant speed is 6. So the expression is 6t. So the total distance the car needs to cover is 108 plus 6t, all right? This is the distance that the car will need to cover. The 108 meters that the cyclist moved on the first 24 seconds, plus this 6t, which is an expression for the distance the cyclist is moving while it is at constant speed. All right? So what is the equation that you have for the car? Since it is moving at a constant acceleration, so you use this one. S equals ut plus 1/2 of at squared. All right? The distance is that one. Plug it here. The initial speed of the car is 0. The acceleration of the car is 4. And now you solve it for t. You solve it for t, and you will have, again, two times. One negative, that is impossible, and another one of 9 seconds. Okay, a positive one. So this is the one that you pick. The total time is therefore the 24 seconds that the cyclist moved plus 9. So that is 33 seconds. Don't forget that the time that you were asked, it takes for when the cyclist starts until the car overtakes her. So the time starts counting when the cyclist starts moving. So that's basically the 24 plus the 9 that you just calculated, which is 33. I want you to pay close attention to this first part over here, all right? Because this is, you have to do this analysis of what's going on in these type of questions always. All right, and I want you to again stress the importance of every time you need to just sketch a graph. A graph is a tool that you can always recur to help you solve questions.